Welcome to this YouTube channel. The topic we are considering now is sequence. This sequence will be done in two parts, sequence 1 and sequence 2. In sequence 1, focus will be on linear sequence. Now the first thing I want you to know under linear sequence, like example, what type of sequence are linear sequence? This is one category, example of linear sequence. We have like 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a linear sequence. And if you look at this sequence very well, they have something we call common difference. That is, the difference between the first and the second is equal to the second and the third. So common difference, the second term minus the first term. This is another one. The common difference here is 2. This is another one. The common difference here is 7. This is another one. The common difference here is minus 9. Note, the common difference can be addition or subtraction. It can be plus something or minus something. Like in this last question, the common difference is minus 9. So this type of sequences are known as arithmetic sequence. Now, we need to know how to find the nth term of arithmetic sequence. Now, you see a sequence, that this sequence is arithmetic sequence, that is, they have common difference. This is the formula. Tn is equal to a bracket n minus 1 d, or Tn is equal to a plus d bracket n minus 1. I advise, if the common difference is minus, I advise you use this one, this formula, so that minus will be in the front of bracket. You not make mistake. Now, a means first term, and d is the common difference, that is second term minus first term. While n is the number of terms. We want to derive the formula for a particular sequence. This is an example. In this example, I have 4, 7, 10, and 13. The first term is 4. The common difference is 7 minus 4, which is 3. So using the formula, I will have 4 bracket n minus 1 bracket 3. Then if I open that bracket, I have 4 plus 3n minus 3. So if I rearrange, 4 minus 3 plus 3n, and the final answer is 1 plus 3n. If I want to test run this, the first term, 4 is the first term. So if I plug in 1 inside that nth term, I should get 4. If I plug 2 inside that nth term, I should get 7. If I plug 3 inside nth term, I should get 10. If I plug 4 inside nth term, I should get 13. Like, let me test 1. If I plug 2 is equal to 7 in the sequence. 7 is the second position. So if I put 2, if I remove n, I put 2 there, I will have 1 plus 3 times 2 is equal to 1 plus 6 equal to 7. So you can test that one to be sure whether the answer you get is correct or not. So this is another one. First term here is 37. Second, the common difference is minus 12. So if you put it in the formula, we have 37 plus n minus 1 bracket minus 12. No, I said earlier more, you can use 37 plus minus 12 bracket n minus 1. So when you open the bracket, this is what you get, 37 minus 12n plus 12. So if I collect like terms, I get 37 plus 12 minus 12n. So the answer will be 49 minus 12n. This way, if I test, let me test the first term. The first term is equal to 37. If I remove n, I put 1 there, it will be 49 minus 12 times 1. 12 times 1 is 12. So 49 minus 12 is 37. So if I test the second, the third one, I can test the fourth one. The fourth one in the term is 1. So if I put 4, if I remove n, I put 4, there will be 49 minus 12 times 4. 12 times 4 is 48. So 49 minus 48 is equal to 1. So that shows that my answer is correct. So we have another kind of linear sequence. The one I mentioned before is that one have common difference, but there's another type. This example. If you look at this one, for me to get the next term, I will need 2 to multiply the previous term. Like 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, another one. This one, if I use 3 to multiply, so in this way, we have common ratio here. This one, I have multiplied by 10. This one is multiplied by fraction or divided by a number. So if I divide 128 by 2, I get 24. Or I say 128 multiplied by half. So in this place, I say common ratio is half in this place. So this type of sequence is known as geometric sequence. So to find the end time of a linear sequence, which is geometry, this is the formula. Tn is equal to AR raised to power n minus 1, where A is the first time, R is the common ratio, and n is the end time we are looking for. That common ratio is the second term divided by the first time. That's how we get the common ratio. This is an example. In this place, A is 16, common ratio is 4, and the n you want to have, just put everything together in the formula. You have 16 multiplied by 4 raised to power n minus 1. To simplify, you can, in the law of indices, when you have something raised to power something and the same thing raised to a power nothing, we can add the power. So I can just take 16 to the base of 4. So 16 will be 4 raised to power 2 multiplied by 4 raised to power n minus 1. And anytime you have something like this, you can add the power together because the bases are identical. So the answer will be 4 raised to power 2 plus n minus 1. So if I simplify this one, the answer is 4 raised to power 1 plus n, or 4 raised to power n minus 1. Either of the two is correct. This is another one. The first time here is 125. Common ratio is 1 over 5. So if I put it together in the formula, 125, 1 over 5 raised to power n minus 1. So if I want to make 5 to be base of 125 to be base of 5, it will be 5 raised to power 3, while 1 over 5 in base will be 5 raised to power minus 1. So if I simplify that one, I can open the bracket behind 5 raised to power minus 1. That will give me 5 raised to power 3 multiplied by 5 raised to power minus n plus 1, or 1 minus n. So if I simplify further, because I have 5 raised to power something multiplied by 5 raised to another, I can add the power together according to the law of indices. So that will be 5 raised to power 3 minus n plus 1, and the final answer is 5 raised to power 4 minus n. Now, I want to treat a past paper, and the past paper I'm considering here is May-June 2018, paper 2 variant 3, number 22. The first part of the question say find an expression for the end time of the term of each sequence. This is A. Now, the first term is 11, common difference is 4. Then we put everything together inside the formula. I have this 11 plus n minus 1 bracket minus 4. I say it's better to, you can write it as 11 plus minus 4 bracket n minus 1. So that one will give you 11 minus 4n plus 4. If you see, that will give you 15 minus 4n. I want to test run. Let us test run the last term. The last term is the last term, which is minus 1 on the sequence that is given there. The last term is number 4. So if you put 4 here, it will be 15 minus 4 times 4. 4 times 4 is 16. So 15 minus 16 is minus 1. So you see that is correct. If I test the first one, number 1, that will be 15 minus 4 multiplied by 1. 4 times 1 is minus 4 times 1 is minus 4. So 15 minus 4 is 11. So if you test run like that to know or to be sure that the answer you get is correct. This is another question. 3, 6, 12, and 24. Here A is equal to 3. This one has common ratio and R is 2. So I will use this formula AR n raised to power n minus 1. So this one will give me 3 bracket 2 raised to power n minus 1. You can leave your final answer like this or like this. It's okay. But if you can simplify further, you can. 2 raised to power n minus 1 means 3 multiplied by 2 raised to power n multiplied by 2 raised to power minus 1. So if 2 raised to power minus 1 means half, is equal to 3 times 2 raised to power n multiplied by half. 3 multiplied by half is 3 over 2. So the final answer can be 3 over 2 multiplied by 2 raised to power n. Although you can leave your final answer like this, it's okay. So this is how far we go in linear sequence 1. I want you to try as much as possible to watch this over and over and try as much as possible to solve as many questions as possible. And be expectant of sequence 2, where we talk about tougher part of sequence. Bye for now.